Good evening. Sorry for the delay. There was important meeting which I could not avoid with your froze German.
Evening, sir.
Yeah.
No issue, sir. बोला
Just 1 minute and let me get organized.
किस चीज के लिए रहे ठीक है बात करता हूँ कल याद दिलाओ मेरे को प्लीज रोशन क्लास स्टार्टेड
Okay, thank you. Are you able to? வணக்கம். நீங்க பேசணும் கேட்டேன். Baat karo something that also here. Thank you. Lighter sense. Okay. So are you able to see the screen?
Yes, sir.
Okay. Yeah, thank you very much. Sorry for the little delay because as I told you that I was in another meeting which is supposed to start by 5:30, end by 6, but it started by 5:15. Just now we ended. Okay, I rushed back. I will just take up to around another 30-35 minutes. Some other day we'll compensate remaining time. Okay. So by one extra class we can have so that we can compensate what we lost today. But today I will stop by 7:05 or 7:10, maximum 7:05. Okay, not more than that. Okay. Now, I told you that previously, the Monday, we started about the AC motors. That is alternating current-based motors. Out of that, there are two types. One is called as synchronous motor. We saw how the synchronous motor works, for which we supply three-phase AC voltage to the stator winding, and rotor we supply a DC voltage. So the rotor get locked, both will get magnetized. Only thing is the stator magnetic field is a rotating magnetic field which rotates at particular speed. That is called a NS, which already know that it depends upon supply frequency and number of poles of the synchronous motor. 120F divided by P was the synchronous speed of the magnetic field which is rotating. So the rotor, which is a DC magnet, correct, which is supplied by electromagnet. Sometimes it can be a permanent magnet also. We are going to see permanent magnet based synchronous motor, which is widely used in automobiles. Maybe next week. Okay. That time we'll see about that. And also we'll see permanent as a motor, DC motor, PM DC motor also. Okay. Today we will see the most important electric motor. If we see electric motor used in any application, whether starting from agriculture, pumping water from well, or in industries, ginning mills, wherever you want the AC motors, what you will see is an induction motor. Synchronous motors are limited. It has also used, I will tell you, two applications where you want constant speed and also for power factor correction. It is used as a power factor correction device in large industrial application where more induction motors are used. Okay, and the industry may have maybe 100, 200, and each motor may be 10 kilowatt, 100 kilowatt, big motor driving ginning mills or industrial production, conveyor belt system, all those things in any industry. It can be food processing or a manufacturing, wherever it is, they use the induction motor. It is very popular because of its ruggedness and simplicity. Okay, it is also type of AC motor. We are going to see how it works. When we talk about induction motor, I say that induction motor, the basic principle of induction motor is principle of working of induction motor, I say IM, is similar to AC transformer. Electrical, similar to electrical transformer, you can note down. Basic principle is same. Right? We know that if I talk about the electric transformer, for understanding, correct? I have a AC supply. This is symbol for AC, correct? You can say that one sine wave is shown here, tide symbol. Then that is given to what you call as a primary coil. This we call as primary coil. And you have a magnetic core. This is symbol for magnetic core. Then you have the secondary coil. Okay. Secondary coil is connected to the load. This is the load, which requires electrical power, which needs electrical power. We need to supply electrical power. It can be anything. It can be a bulb or heater, motor, whatever it may be. It needs a AC voltage. So in that case, primary we supply. This is the power, AC power from grid. We say electrical grid, right? Power is generated by a alternator in power station. It can be hydroelectric power station, thermal power station, or nuclear power station, or nowadays wind energy also. Wind energy, all these things are driving, correct? We know that there will be a turbine which will be driven by steam or higher water, pressurized water from dam will be driving the turbine. Turbine is connected to electrical generator. We call it as AC generator. AC generator is also other name for AC generator is called alternator. All of you know the alternator is used in all electric, all the automobiles. Automobiles are having alternator. Alternator driven by engine, which generates an AC power. Alternator AC power that will be rectified using a electrical diodes, rectified, and we get DC voltage. After rectification of DC, that will be used for charging the battery. Correct? In your car, any car and automobile, you have a battery which will be used for spark plugs in case of the bulbs or any other motors, fuel pump. Correct? Most of the device inside your car, motor, solenoids, or spark plug requires a DC voltage. DC voltage supplied from the battery. Correct? That is supplied from the battery. Correct? So the battery is a DC source, and that power, because once you start using the power, automatic voltage drops. So after some time, when voltage comes below a certain level, it has to be charged, recharged. Correct? So for that, you are using alternator. So this same alternator only used in a power station also. Hydroelectric, thermal power station, wherever, or nuclear power station, or wind energy, AC generator driven by a prime mover. We call it a prime mover. The prime mover can be anything, correct? Can be turbine. The turbine can be hydroelectric turbine. That means hydro or steam turbine. Steam turbine will be driving the alternator. Alternator generates AC voltage. That is what we are getting in the home, correct? This power only is coming here from the alternator generated. The voltage is coming down. In between, you have the transformer, correct? So this power is coming from the electrical grid, correct? So this is this one, and it is given to a transformer, correct? This is the transformer, electrical transformer. Please note that the electrical transformer is used for stepping up or stepping down the input voltage. Input voltage to correct level, correct amplitude, so that it can be supplied to load. For example, I am getting AC power in India is 220 volts. I am talking about single phase, correct? So one is called neutral, other one is called phase wire. That is what is from electrical grid. So this voltage is 220 volts. With respect to neutral wire, the phase is single phase means you have 220 volts. This is called as RMS value. Root mean square value. Okay, we will see what it is, why it is called root mean later. Okay, now if we give this, then the voltage applied to the primary coil has 100 turns, secondary coil, correct? Primary coil has 100 turns, secondary coil has 50 turns. For example, both are wound over a core, transformer core. Then we say transformer ratio, TR equal to, this I call N1, primary coil N1, number of turns, N2 is the secondary coil turn. N2 divided by N1 is called as transformer ratio. This is already all of you know, very simple, already you would have studied, correct? So now, what is transformer ratio for this transformer? 50 divided by 100. Primary coil 100 turns, I told you, N1. N2 is this one. So transformer ratio is 0.5. So now, if I give a voltage, I call V1. The correct V1 is the primary voltage. Voltage induced in the secondary coil called V2. So I want to find the V1 and V2. I can find using V2 equal to V1 multiplied by TR. Note down. It is very simple, correct? Transformer ratio divided by number of turns. Primary turn and secondary turn. Secondary turn divided by primary turn is called a transformer ratio. If the TR value is greater than 1, sorry, less than 1, it is called as transformer. Step down transformer. Okay. Instead of that, if the TR is greater than 1, it is called as, sorry, it is called as step up transformer. Okay. That means this transformer, step up transformer, will amplify the input voltage. Amplify input voltage or primary voltage by the transformer ratio times. So if I say that my V2 equal to TR multiplied by V1. Okay, V1 is input voltage. That is the primary voltage which you are supplying from grid. Now I said that input voltage is, here I said 220 volts. Correct? I am giving input voltage 220. This is multiplied by transformer ratio for this transformer is 0.5. So what I will get V2, which is called as secondary voltage. Secondary voltage or correct secondary coil voltage is going to be 110 volts. So what is this transformer? It is called as a step down transformer. Why I am explaining is basic principle of the induction motor exactly same. Okay. Only thing is here there's a in transformer there's no moving part. In case of induction motor, you have a rotor. Rotor is nothing but the secondary coil of the transformer. It has a stator coil similar to synchronous motor. That is the primary coil of this one. So that's why I'm explaining this. So this transformer, since it is going to reduce the output voltage 0.5 times, which is nothing but transformer ratio, this is called as a step down transformer. Okay. Instead of that, for example, the N2 equal to 200, N1 equal to 100 turns. Then I have another transformer. What is my TR? TR equal to 200 turns. That is nothing but N2 divided by N1, which is nothing but primary. That is 100. So the transfer ratio is 2. Now, if I give the same 220 volts input, input is 220 multiplied by transformer ratio is 2 is the V2. It is going to be 440 volts. So this transformer, which has transformer ratio equal to 2, this is called a step-up transformer. Okay. So from this, what we understand, the transformer can amplify the input voltage by a factor. The factor is called as transformer ratio. Correct? Transformer ratio is nothing but number of secondary coils divided by number of primary coils. So while you are making a transformer, you decide what should be transformer ratio. Transformer ratio TR can vary, correct? It can be equal to or greater than. TR can be, it should be, it cannot be equal to, okay, we can say that it should be greater than 0. So transformer ratio can be vary from greater than 0. TR can be greater than 0 and TR can go up to infinity. But nobody is going to make it, correct? If you want an input voltage 1 volt, I want infinite voltage, I make N2 should be infinite number of turns. Never need, but I can be anything, correct? So transformer ratio should be greater than 0, correct? So if the transformer ratio is greater than 0, less than 1, that is called as step down transformer. And if transformer ratio is greater than 1, then it is called as step-up transformer. This is how the transformer works. So what you understand it? How it works basically, the transformer. So when I supply a AC voltage to my primary coil, this is my input voltage. I said, understanding purpose, I say that 100 volts easy, but India, we get 220 volts or 440 volts if you have a three phase. And this is supplied to my primary coil, which has N1 equal to 100 turns, right? This is my core. I have the secondary coil, I said connected to a load. This is a resistive load. That means it is a pure resistive load, is a resistive load, right? And I connect to this. So there'll be here I call this V1. This is V1 supplied to primary. V2 is called as induced voltage. Okay, induced voltage. This is V2 is proportional to TR multiplied by V1. In fact, actually equal to TR is the transformer ratio. Already we know that. Okay, how it happens? When I supply a input 100 volts and this has 50 turns, right? So the TR equal to 0.5. Okay, if that means V2 equal to 0.5 multiplied by input voltage V1. This is nothing but V1. This is nothing but TR multiplied. That is going to be 50 volts. If I measure the voltage here, I'll get 50 volts. What voltage it is? I told you this is AC voltage. Input is a AC voltage. Output also will be AC voltage only. You won't get DC. Another important thing you note down, already while talking mechatronics, I would have told you, I don't know, when we talk the LVDT, all those things, definitely I would have told you. Transformer can be used for stepping up or stepping down AC voltage only, AC voltage only, or AC power only. I will say Y power only. Note down, this only is very important. You cannot connect a DC power at the primary, correct? You cannot connect a DC power. DC power is represented by plus minus a battery, correct? VDC. You should not connect. If you connect this, what you are doing is you are short circuiting the DC voltage and the transformer may burn your DC voltage battery. If, for example, you connect your, say, for a 24 volt battery, heavy current will flow and the battery will fail and your transformer also, there are chances of failing. So you should not connect DC voltage to a transformer. Never connect DC voltage to a transformer. That is most important thing. So transformer can amplify only AC voltage. That is very important. Note down. Okay. So DC voltage should never connect, because I have seen one of my student, I'm talking some 15 years ago, one MTech student, MS student who was working with the battery, connecting some electrical circuit which has a transformer. He connected a battery voltage. We have 24 volt car battery. He connected, and because of that, the battery burned. He got burned in hand. All this thing. We told him you should connect AC. By mistake he connected. That's why you should be careful. That's why I'm just telling you. You should never connect battery to transformer. Why? I'm going to tell that also. Okay. Now, if I connect this, that means the current is flowing. I say that IAC. This is VAC. That is applied voltage. This is current flowing to circuit. The IAC equal to VAC divided by Z. Already told yesterday also, the Z is called as impedance. Impedance of the primary coil. This is called a primary coil. Correct? Primary coil. Primary coil. What is the Z? Already told you. This coil is, yesterday also I told you, coil is, you take a copper wire having some thickness, correct? Say 0.5 mm or 1 mm thickness, say 1 meter length, and turn into 100 turns very closely. You made it a coil, correct? 1 meter or 2 meter coil. You took one, it was wire, it has only resistance. Just if it is straight wire, correct? That means it has some thickness, correct? Cross-sectional area, small a, and this is the cross-sectional area of the wire. It is solid cylindrical wire, correct? For understanding, it can be any shape. It has a cross-sectional area and it has a length. It has some resistivity, correct? We call it a rho, resistivity. We have talked about it. Then it has a length, and this is the area, cross-sectional area. Then R equal rho L by A. This is called electrical resistivity. Okay. When it is a straight wire, it has only resistivity. But if the same wire, if I make as a coil, it has both. It has what you call inductance. Inductance represented by capital L, and it has a resistance also. Because same wire only. Because it is made of copper wire, it has resistivity, length, cross-sectional area. Due to that, for example, I say that this is 10 ohms. Now, if you make it as coil, again, it has the same resistance, 10 ohms, because same wire. The electrical resistance doesn't go whether it is a straight wire or a coil, but now it acquires new property called inductance. This may be, for example, 100 millihenries, mH, unit for inductance henries. It has 100 millihenries. So now the wire is becoming inductor, and it has acquired new property called inductance. Once two things are there, it has resistance, also inductance. Finally, when it is a pure resistance, the current I for this, I am applying a voltage, for example, battery voltage. I have a battery. I am supplying 12 volt DC. This is plus minus DC voltage, correct? There will be a current going IDC because of resistance. What is that IDC? IDC equal to VDC divided by R. VDC is 12 volts. Already I said resistance equal to 10 ohms. 10. So 1.2 amps current is flowing, correct? Through the wire, current flowing is 1.2 amps. Okay, that's it. Now I made it as a coil. Once I made a coil, it has two properties. One is inductance, other one is resistance. Okay, that means if I apply, correct? If I apply the same DC voltage to this, okay, to the inductor, there will be a current flow, correct? I say current is flowing, that is IDC. IDC equal to, again, same 12 volts, 12 divided by XL plus R. The denominator, when you calculated DC power, what was the formula? VDC divided by R. R is the DC resistance. Resistance is also called a DC resistance. Some books, correct? It is called as a DC resistance, correct? It is remains same. Okay, whether you supply a DC voltage or you supply AC voltage. I am going to show next slide. This is a AC voltage. Now I supply DC voltage to the coil. Right now the current IDC is calculated by IDC equal to VDC divided by R plus XL, because now it has two property. What is my XL? XL equal to 2 pi FL. Note down the formula, where 2 is a constant, pi is a constant, F is the supply frequency. It is called supply frequency. 2 is a constant, pi equal to 3.1. This is supply frequency. What is supply frequency? We are supplying a DC voltage. What is the frequency of DC voltage? We will see what it is. Then we call what is L. L is called inductance value, measured in terms of henries. Okay. Now, already I told you this inductance is 100 millihenries. Now I know R equal to 10 ohms. That remains same. XL is called as AC reactance. This is called as resistance. R is called as resistance. AC, XL is called as AC reactance. Reactance called XL. Resistance. That formula is, I told you, 2 pi FL. If I substitute 2 into 3.14, F equal to, if you supply DC voltage, F equal to 0. For DC voltage, F equal to 0. Battery voltage, any DC voltage, because the voltage doesn't change with respect to time, it remains a constant, F equal to 0. 0 multiplied by, I said L equal to 100 milliamps, 100 into 10 power minus 3. Okay. Now, there's a 2, 3.15, 100, but you are all are multiplication factor. Because there's a 0, my XL will become 0. If I supply a DC voltage to a inductor coil, which has some resistance, also some inductance, now current to calculate IDC should be VDC divided R plus XL. XL is 0, but R equal to 10 ohms remain as it is. So what is my IDC? Even when the wire is made as inductance, my IDC of the coil equal to 12 VDC divided by 10 plus 0, that equal to 12 divided by 10, 1.2 amps. Please see that whether the wire, taken a copper wire, just a long wire, and supply 10 volts, wire it's at 12 volts, and the resistance equal to 10 ohms and the voltage 12, the current will be IDC will be 1.2 amps. For the same wire, I made as a coil, it became an inductor. The resistance remained as it is, but is acquired new property inductance, which is L equal to 100 milliamps. So it, for that, if you apply a voltage, it produces, it opposes a current flow, which is called as AC reactance, which is represented by capital X. Going to see what we call the XC. This is called a capacitive reactance. Right now, coil, this we are not talking about that. So that's why X substitute L means inductive reactance. Whenever coil is there, this also to be taken care. Okay. So now the XL equals 0 because supply equals 0. So that means whether the wire was a straight wire or is a coil, the current, if I apply 10 12 volts, the current will be 1.2 amps. So this is for DC voltage. Okay. Now, what if in the same coil, correct? I am applying a AC voltage instead of DC voltage. I am applying same inductor. I apply coil L equal to 100 millihenries, which can be represented 100 into 10 power minus 3, correct? Henries. Both are same. Okay. So then it has a resistance R equal to 10 ohms. Whatever we talk. Now I am applying a 12 volt AC. Correct? 12 volt AC from AC source. Its frequency equal to 100 hertz. The frequency AC means automatically its number of cycles per second comes in. We know that electrical grid, it is 50 hertz. You can take even this, you can take as 50, no issue. I took it 100 because multiplication something you do, but you can have this one. Now, I am instead of supplying a DC voltage, I am supplying AC voltage. Now, this is my VAC. VAC equal to 12 volts. There will be a current flow IAC. IAC equal to VAC divided by Z, because I have inductor, not a resistor. It has two properties: inductance plus resistance. Since inductance is there, we need to calculate. We know that VAC equal to Z. Z can be represented R square plus XL square. Take the formula. Z is called as impedance of the coil. Impedance of coil. Correct? So coil has resistance R and also it has XL. That is called reactance or AC reactance. Right? It has two properties. If I combine both, that is called as impedance. Impedance of the coil is nothing but root of R square plus XL square. That is what I am substituting. So to find the AC current, the input to the AC voltage will be divided by Z. Z is this one. Now, according to this, now we can calculate what is R. R equal to, already we said 10 ohms. What is my XL? XL equal to 2 into pi into F into L. 2 into 3.14 multiplied by F. Here I am applying AC frequency, F equal to 50. Right? So I need to apply 50 into L equal to 100 into 10 power minus 3. Okay. So we can say that this is going to be 6.24 multiplied by 50 into, correct, 0.1. Correct. I can say that 6.24 multiplied by 5. Correct. So many ohms. So impedance also represented, unit for impedance also ohms only. Correct. Ohms is symbol. Unit is same. Reactance, resistance, and impedance. For all these things, the unit is ohms. Okay. Now you can say that this is going to be 5. Okay. around 31 ohms or 31 point something. I say that 31 ohms. Correct? So now what is my current IAC? IAC flowing through the inductive coil is VAC is 12 volts divided by root of 10 square plus 31 square. So many amps. You can see that same the voltage is 12 volts only, but it's an AC voltage with a frequency 50 hertz. Automatically, the current is considerably reduced. Correct? If you see here, definitely it will be less than DC current. But 1.2 amps of the DC current. Correct? When I apply DC voltage, if I apply same coil AC voltage, the current reduces. So, yes, can somebody say 12 divided by 10 square? I can say 10 into this one, 100 plus. Let us calculate. Somebody can tell, you have the calculator? So you can see that the current will become
0.01, sir. 0.011.
0.12 amps. Thank you very much. Kind of you. Okay. So current will become. This is for 50 hertz. For example, I have a power supply which 100 hertz. What will happen? Correct? If it 100, if the frequency increases, the X R will remain same. Please note that R never changes. Whether AC volt, DC voltage, but XL alone 2 into 3.14, my F is become 100 multiplied by 100 into 10 power minus 3. Right? So we can say that it is going to be 2 into 3.14 multiplied by 100 to 10,000 into 10. Correct? So it is going to be 6.24 multiplied by 10, 62.4 ohms. Correct? My denominator, my IAC is going to be 12 divided by 64, almost double. 62. The current will be again half of this. So from this, what you understand? My voltage, AC voltage amplitude, 12 volt is called the amplitude. Amplitude is constant, I am keeping, but I am wearing F alone. Correct? F can be in India 50. If I go to US, it is going to be 60. If you go to France, 70. Or you generate AC voltage, correct? In which I generate my supply figure 100 hertz. What will happen? Automatically, XL will increase if supply frequency increases. XL will decrease if supply frequency decreases. So it is directly proportional to supply frequency, AC frequency. So that means if I use AC voltage in inductor, not in the resistance, correct? Resistor value never changes because resistance for R equal to rho L by A, correct? There's no F in this rho L A, all are fixed, correct? Wire length, wire area, rho is the resistivity of the wire material, copper, aluminum, that is. So R going to remain constant, irrespective of whether you are applying AC voltage or a DC voltage, correct? So in the impedance, this part is constant, but XL, which is called the inductive reactance, varies with respect to the supply frequency because the AC reactance XL, the formula is 2 is constant, pi is constant. Inductance value, I said fixed, already made a coil, 50 turns or 100 turns, it has inductance 100 millihenries. That is going to, but if I vary my supply frequency, this value, if this increases, XL will increase. If the decreases, the decreases. Automatically, IAC will increase or decrease. Correct? If F increases, I will decrease. If F decreases, I will increase. Okay? So this is how the transformer works. Okay? The AC circuit works. So main thing what you note down is the impedance is the Z is directly proportional to supply frequency if my load is a coil. Inductive circuit. Motor is an inductor. Transformer is an inductor. Whether DC motor, AC motor, everything is inductors. So they have both. It has resistance, also inductance. because of there's an inductive reactance.
Sir,
Yes, please.
I have a question. Can I ask if you allow?
Definitely, please.
Sir, just one theoretical, like fundamental question that for calculating the impedance in the AC circuit,
Correct.
you have used the formula x is equal to like
XL equal
impedance, Z is equal to root under R square plus XL square, right, sir?
Yes.
But for the DC, we have used R plus XL. I know that XL doesn't have any meaning in DC supply.
Yes.
But whether whether we have to use the same formula like R square plus XL square for DC as well, theoretically I'm asking, or we have to use just R
no.
plus
For
XL.
example, yeah, very good, fantastic question. For example, you have a DC motor, correct? You have a DC motor. You are supplying a DC voltage. Okay, plus minus, and the DC voltage if you supply V equal 10 volts. For example, your DC voltage with respect to time equals 0. This is a time axis. You supply at t equals 0. The motor, you have a switch, correct? You are connected at t equals 0. You close the switch, so you are applying a DC voltage, the 10 volts. So, and this RA, armature coil resistance equal 10 ohms. What will happen? The current I equal to IA, sorry. Yeah, the IDC or IA armature coil, because your DC motor is going to be 10 divided by 10 ohms, 1 amps current should flow. Okay, but please note that what they have a beautiful question, important question. The DC motor armature also, it has a coil. Coil automatic inductance comes to, that means you need to consider Z only. Even for this, the VDC divided by Z only. Okay, because my armature is a coil. So that means it will be VDC divided by root of R square plus XL square only. But if the supplied voltage is a constant, correct? The voltage is constant, not varying with respect to time. Automatically, the XL will become 0. Okay, so that means what will happen? VDC divided by root of R square. It is nothing but VDC by DC R only. That's why we always calculate. But this is valid. This formula is valid as long as the voltage is not changing. For example, sometimes DC motor speed. DC motor speed is, the speed is proportional to torque. Correct? The torque is proportional to IA. For example, I wanted to vary the motor speed, DC motor speed. The maximum voltage I can supply is 0 to 10 volts. For example, initially from time t equal to 0 to 10 seconds, I supply 5 volts. After that, what I did, I want to increase the speed. That means I have to increase the current IA. So what I did, I increased the voltage. Let me clear this, you will understand. From 0 to 10 seconds, you applied 5 volts. The current was 0.5 amps. So what was running, for example, 500 RPM. Now I want to increase the motor speed. Motor speed depends upon torque produced. Torque is proportional to IA. IA is proportional to supplied voltage, armature voltage. Initially, I applied 5 volts. After 10 seconds, I want to increase motor speed. What I have to do? I have to supply 10 volts. That means suddenly at 10 seconds, I increase voltage to like this, stepped up. Then it remains constant. This period is called as a transient period. Correct? Transient period, there is a sudden change. That means the F at this can be theoretically F equal to infinity. When the slope of the voltage is vertical, correct? That is nothing but the frequency change. Correct? The voltage suddenly 5 volts is changing to 10 volts. Any voltage, sudden change happens, correct? There's a AC voltage, it becomes AC voltage. What is the frequency of that? Infinity. Then what is my XL? XL equal to 2 into pi into infinity into the coil inductance. My armature inductance, say L equal to 100 millihenries, for example, into 100 into 10 power minus 3, correct? But generally, theoretically only we say that the vertical line, sudden change. But actual practically, it may be voltage will rise in some millisecond duration or microsecond. Okay, the frequency will not be infinity. Correct? F will not be infinity. It can be in the order of 100, 200, 300. How quickly the switch voltage changes. If I take theoretically, you will see that current will be abruptly stopped. Correct? During the transient time, the XL comes into action. That means that time the Z should be computed. XL generally will not be infinite. Theoretically, it's a vertical. Practical case, the voltage, even if it's change voltage, the voltage was like this. It may increase like this. This duration may be few milliseconds. Automatically, the slope will be calculated. The F will not be infinity. It may be in the order of 100, 200 something. Automatically, the XL will come into picture. Now, that time, the current going through even the DC motor, it is not same as the just resistance. You have to compute the impedance. That time you have to calculate what is the XL, add with this one, use this formula. Okay. But as if the motor is not changing frequently, right? The supply voltage DC motor is not changing frequently, very slowly it is changing. Then you will consider this formula only. What formula? As I told you that VDC divided by RA alone. XA you will not compute. If the DC voltage applied, for example, if DC voltage applied is initially it was 10 volts, it becomes 12 volts, it becomes again becomes 2 volts. It is something like this. You are changing motor. Wherever transients are happening, that time the current calculation you have to use VDC divided by root of R square plus XL square, and you should find out what is the XL and you have to do that. Okay.
Roman Andre, sir.
Okay. Thank you. Okay. I'll stop here. Okay. Tomorrow, Monday, we'll continue. Okay. Thank you very much. Please give your attendance and go.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Okay. Thank you. Nice.
Thank you, sir.
Sir, hello.
Yeah.
Sir, can we get any circuit diagrams for learning?
Next class, we will talk about that. Next class. Okay.
Sure, sir. Thank you,
Okay.
sir.
Thank you. Please give your attendance before leaving. Okay.
Sure, sir. Thank you, sir.
Okay. Thank you. Take care. Have a nice weekend. We'll see you on Monday evening, 5 o'clock, 6 o'clock.
Nice weekend, sir.
Okay.
Thank you.
One minute. Okay. I'm closing the class. See you on Monday.